In Lesson 3.5, you will be adding and subtracting like fractions. You'll add rational numbers with common denominators, and you'll subtract rational numbers with common denominators. While this is not a new concept, I do want you to become familiar with the key concept here and how this is explained in words. To add fractions with like denominators, add the numerators and write the sum over the denominator. I also want you to be familiar with the symbols. A plus C over B plus C is equal to A plus B over C. Remember that C, the denominator, cannot equal 0 because that is undefined. Finally, look at this example. Although I know that you probably know how to do this, please take the time to understand mathematically how to explain this concept of adding like fractions. For example 1 at the bottom of the page, look through the two examples. Nothing new on letter A. 7 plus 6 is 13. Keep the same denominator, 10. Pretty easy. We will introduce some negative fractions here, so as long as we have the common denominator, make sure to assign that negative number to the numerator. So we have 5 plus negative 7 over 8, which is negative 2 over 8, which reduces to negative 1/4. For 1a, got it, we have 5 plus 4, which is equal to 9, and 9/6 reduces to 1 3/6, or 1 1/2. For 1b, we'll assign that negative sign to the 6, so we have 4 plus negative 6, which is a negative 2. Keep the same denominator, 7. For 1c, we have 1 plus 4, which is 5, and the denominator is 5, and 5 divided by 5 is equal to 1. And 1d, assign that negative sign to the 5. Negative 5 plus 11 is 6, and 6/8 reduces to 3/4. For example 2, recall that when you are adding mixed numbers with common denominators, you can add the whole numbers, 2 plus 3, then add the fractions, and then you can simplify that to write your answer in simplest form. Also, when you're adding and subtracting mixed numbers, you can write them as improper fractions before adding or subtracting, and then if any of the numbers are negative, this might be the easier method to use. It's all a matter of preference. So for 2a, got it, 1 plus 4 is 5, and 3/4 plus 3/4 is 6/4, and 6/4 reduces to 1 1/2. So we'll add the 1 and the 5 to get an answer of 6 1/2. 3 times 5 is 15, plus 2 is 17/5. 8 times 5 is 40, plus 1 is 41/5. 17/5 plus 41/5 is 58/5. And that reduces to 11 3/5. While that alternative method maybe wasn't designed for this type of problem, I think it is designed for this type of problem when we have negatives. 2 times 7 is 14, plus 3 is 17, so negative 17/7, plus a negative. 4 times 7 is 28. 28 plus 5 is 33, 33/7. Negative 17/7 plus negative 33/7 will be negative 50/7, and that is equal to negative 7 1/7. Again, not too terribly new information, but just keeping track of those negative signs and also paying attention to some different strategies that you can try when you're adding mixed numbers. Again, please become familiar with the key concept of subtracting like fractions, especially being able to put it into words. When you're subtracting fractions with like denominators, subtract the numerators and then write the difference over the denominator. Also, the symbols a over c minus b over c is equal to a minus b over c, where c is not equal to 0. The rule for subtracting fractions with like denominators is similar to the rule for addition. Take care of the numerators. So for example, 3/10 take away 9/10. Take care of the numerators. 3 minus 9 is negative 6. Keep the denominator of 10, and negative 6/10 equals negative 3/5. Down at the bottom, 3a, this denominator is 15. Numerator 5 take away 10, which is negative 5. Negative 5/15 reduces to negative 1/3. For 3b, 3 minus 4 is negative 1, and the denominator is 9. For 3c, 7 minus 3 is 4, the denominator is 8, and 4/8 reduces to 1/2. Example 4 has you evaluating algebraic expressions that involve computations with fractions. So make sure to watch out for those negatives and pay attention to your rules for adding and subtracting fractions. So you have an example here of x minus y, 3/5 minus a negative 4/5. Don't forget that that double negative turns into a positive. So for got it, example 4, 4a is a minus b, so that is 3/8 minus b, which is a negative 5/8, which turns into 3/8 plus 5/8, and that is equal to 8/8, which is equal to 1. For 4b, we have b minus c, which is negative 5/8, take away c, which is 7/8. Negative 5, take away 7 more is negative 12, and negative 12/8 can be reduced to negative 1 and 4/8, or negative 1.5. For 4c, c minus a is 7/8 minus 3/8. 7/8 minus 3/8 is 4/8, which is equal to 1/2. Again, not too terribly difficult as long as you're willing to show your work and keep track of those negative signs. Be prepared to kick this up a notch in class when we involve more variables and put it all together with adding, subtracting, multiplying, and dividing with fractions. For example 5, we have a story problem involving the division of fractions. For the got it problem, the Daytona International Speedway is one of the longest tracks used in NASCAR. It is 2 2/4 miles long, or 2.5 miles long. And the Richmond International Speedway is 3/4 of a mile long. How much longer is the Daytona Speedway than the Richmond Speedway? So I did change that into 2.5, but then that left me with not having a common denominator. But you have to know there's some different methods for these types of problems as well. So I could actually do this problem thinking about money. $2.50 take away 3/4 of a dollar is 1 3/4. Okay, but I'm going to go back to the method of showing the traditional subtraction of fractions. I'll do 2 2/4, take away 3/4, and this is where a lot of students forget how to borrow with fractions. So I borrow from the 2 and make that a 1, and when I borrow 1, I borrow 4/4, and there's 2/4 that are already there, so I have a total of 6/4. 6/4 take away 3/4 is 3/4, and 1 take away nothing is 1. I get the same answer, and to me this makes more sense right here the way I did it first, but just know that there are always multiple strategies and methods of doing things in math, and the more strategies you know, the better mathematician you become. For example 6, you're finding the distance between two fractions on a number line, and I should mention that there's always this icon showing you that there's an additional video tutor on your online textbooks. It's the exact same place where you access the self-check quizzes. You can just find this icon with the speech bubble, and that will give you another video explaining an example like the one shown. For example 6, step 1, it is telling you to make a number line and graph the fractions on that number line. Sometimes that can be cumbersome to make all those tick marks, but it is a great way to help you visualize the problem and then count the parts between the fractions. So for the got it problems, I didn't go through and make all the tick marks on each of the problems. It was a little bit easier for 6a because it was divided into fourths. Here is 0 and here is -1, and there are 2/4 jumps in between those two fractions, or 1/2 of a unit. On 6b, I didn't write all the tick marks, but you can visualize here. -7/20 back to 0 is 7 jumps, and then 0 to 9 is another 9 jumps. 7 and 9 is 16, and 16/20 reduces to 4/5. So 4/5 of a unit between those two fractions. And finally, 7c, negative 11 back to 0 is 11, plus another 2 more jumps. So that's a total of 13/15 of a unit between those two fractions.